Hello, hello, chemistry students. Today we're going to talk about stoichiometry and mole ratios. This is one of those concepts that can be a little bit difficult to grasp first in chemistry, but it's actually, despite the use of big words like stoichiometry, a really straightforward concept. Okay, so here, just wanted to highlight we're looking at Module 2, the Introduction to Quantitative Chemistry, and we are currently looking at the first two inquiry questions, chemical reactions and stoichiometry, and the mole concept. Okay, so by stoichiometry, all right, and yes, that's a real word, we mean the relationship between reactants and products in a quantitative sense. The word itself actually comes from stoichein. It's a Greek word that means element, and metron, which means measure. So stoichiometry is typically translated to mean the measure of elements. And we're talking about the coefficient of the relationships involved in our balanced chemical reactions. That's the numbers in blue in the reaction down the bottom. I don't know about you, but big words like stoichiometry, that's hard. That's really hard to talk about what's going on. Let's talk about something simple. Let's talk about cookies instead. Okay. All right, so as it happens, the classic recipe for perfect cookies, okay, the cookie dough recipe is 1 part sugar to 2 parts fat. And by fat, we mean butter to 3 parts flour. All right, and this is an example of ratios used in cooking, okay, because we don't always have the right amount of materials, but as long as we have 1 part sugar by mass to 2 parts fat and 3 parts flour, we're going to get some pretty decent cookies. Okay, so let's take a look at this. All right, so remember, cookie dough, the perfect ratio for the perfect cookies, 1 part sugar, 2 parts fat, 3 parts flour, where fat is butter. Okay, so how much flour are we actually going to need if we have 200 grams of butter? Okay, so let's take a look at this. All right, you're welcome at this point to pause the video and have a go yourself and resume. All right, so that being said, pause the video and unpause when you're ready. I'll wait. All righty, so this is how we actually do this particular set of problem here, okay? So we have our ratio, and if we just take a little look here, so it's 1 to 2 to 3, okay? How much flour do we need for our first problem if we have 200 grams of butter? All right, well, we need 3 parts to every 2 parts. Okay, so we know we have 200 grams. We need to work out how much flour we need. Well, it's just a simple ratio. We can use a fraction to work it out. 3 on 2 times 200. And this will give us exactly how many grams of flour we're going to need, which will work out to be 300 grams of flour. Pretty straightforward, right? All right, let's take a look at the other one just here. So if we're talking about how much butter we need, if we have 1 kilo of flour, well, let's look at that. All right, we have 1 kilo of flour, 3 parts flour to our 2 parts butter. All right, so 2 over 3. All right, we'll work this out in grams to make our lives easier. All right, which is going to give us 666 to the 0.6 to the repeater. We just round that to grams, 667 grams of butter. Okay, so this is pretty straightforward, right? We're just adjusting recipes. You do this all the time when you're working in the kitchen, you're baking anything. You have to adjust your recipes to what you have. So how does this fit to chemistry? Well, let's look at that. All right, and the one thing I want to highlight is that when we talk about mole ratios, okay, and by mole ratios, I mean the number out the front of each of our particle in our balanced chemical reactions. They're the numbers in blue for the equation above, okay? We are actually talking about the exact same thing, ratios of products, but not in mass, in moles. All right, so let's take a look at our reaction just here. We have 2 moles of hydrogen sulfide reacting with 3 moles of oxygen to form 2 moles of sulfur dioxide and 2 moles of water. So our mole ratio in this case is going to be 2 to 3, 2 to 2. So if we have 1 mole of oxygen in this case and excess hydrogen sulfide, okay, and you'll see many chemistry problems like this. All right, well, they'll give you a molar quantity of one of your reactants and tell you that the other one is available in excess. And all they mean is that you have as much hydrogen sulfide as you need or more. All right, so this means that the oxygen is what is going to limit this reaction from proceeding and forming products. All right, so in this case, the oxygen is called the limiting reagent. We'll circle back and make another video on that concept. All right, so in this case here, to work this out, we need to work out how much of our product, sulfur dioxide, is going to form when we have 1 mole of oxygen and as much hydrogen sulfide as we need. So let's take a look at the ratio of the oxygen to the sulfur dioxide, 3 to 2. All right, we want to work out how much of our sulfur dioxide that's going to form. Well, it's pretty straightforward, people. We have our material we're interested in, okay, in terms of its number of moles, divided by the moles of the material where we know what we have. We times it by the quantity of moles that we know what we have, so 1 mole, and that's going to give us 0.6 repeater. We'll just do it to 2 decimal places just right now, so 67 mole of oxygen. Pretty straightforward, right? Okay, same idea as we're looking at a ratio across the recipe of cookies. All right, but of course in science we use big fancy words, all right, like stoichiometry, when we're really just meaning the ratio of materials. And it's a little bit more complex than a recipe in that we're not talking about mass ratios. We're talking about mole ratios, and mole is a measure of the number of particles we have present. So remember, when we're talking about moles in a chemical reaction, we're talking about groups, fractions of 6.022 times 10 to the 23 particles. Alrighty, that about wraps us up. Thank you for watching the video. Hopefully that was helpful in showing you that mole ratios, and when we talk about stoichiometry, we're really just talking about the ratio of moles across a reaction, and it's really quite similar to the way in which ratios work in recipes, particularly in baking. All right, let's get on with the lesson, people. Bye-bye.